Okay, hello. We will do the 4 by 4 in this video cube. This cube, in fact, for those who know the difficulty of the cubes with pair numbers, like by 4 and 6 by 6, 8 by 8, etc., they present at the end the problem of parity. This does not exist on an odd cube, like a 3 by 3 or 5 by 5. It exists on the pair cubes. This is mainly because there is no center predefined in this cube. We have to choose the center, while in the 3 by 3 the center already exists and it is predefined. This is not the case in a pair cube. So we have to do a center, and we will not be sure if this center is really in its right place. So okay, we will start by doing building the pieces of the center. The algorithm that we will use is a simple one. So I will put this piece from here, I will put it there. So it goes like this. It's up, U prime, down, U, down, U prime. And this, the piece that was here is now here. In fact, it's a permutation. It's not only one piece getting there. There are three pieces that are recycled. Generally, there are this one and these two. I have a green which is here, so I will put this piece from here to there, up, U prime, down, U, down, U prime, and I have this green center built. Now I have to put the blue on the opposite side, so the blue should come here. Okay, so it's up, U prime, down, U, down, U prime. And I have this blue here that comes here. It's up, U prime, down, U, down, U prime. And the last one here, I can put it there. Up, U prime, down, U, down, U prime. Okay. Now we have to choose where we will put the white and yellow and the orange and red. Let's see if, let's try to see the corners. Maybe they could help us. For example, this corner tells me that green should be here, red should be here, and white should be here. Okay, so I will do the red here. I will put this piece there, up, U prime, down, U, down, U prime. And the last one is here. I can do the same algorithm even if I have the red center on the bottom and I want to put it up. All I have to do, or the only difference is that instead of doing one up, I have to do two ups. So this guy here will come here, two up, U, two up, U prime, two down, U, two down, U prime. And I have built this red center here. Okay, green, red. I will put the white here. So this guy will come here, up, U prime, down, U, down, U prime. And the last white is here. In fact, I will put it from here, I will put it there. So it's two up, U, two up, U prime, two down, U, two down, U prime. And I have built this center. Now all I have is to put the yellow here. In fact, it should be opposite to the white. So I have to put these three pieces from, I have to put them from here to there. So I will start with this one, up U prime, down U, down U prime. Now this one here, up U, up, U prime, down, U, down, U prime, and the last one here to there, up, U, prime, down, U, down, U prime. And you see that all the centers are now built. Now we have to do the edges. I have two elements of the edge, while in a 3x3 I had only one. So here I have to couple the edges together. So to couple them, there are two algorithms. In fact, we will do the most simple one, which is I will try to see where do I have something like this. Okay, I have it here, in fact. So this piece, orange and yellow, if I move it 2 times, it will match with this existing one here. Now what I have to do is I have to get back to this situation. So I put it away and I bring another piece from other places and I put it on this side and I do my 2 turns. And what I see is that I did not disturb the centers which I built, and I succeeded to couple these 2 elements. So we will continue with the others. We see that here we have a green and orange, and here we have a green and orange. These 2 should match. So if I do this, they match. Okay. And I bring it here. I bring another element to this position and I do this. So until now we have built this edge and this edge. So we have to stock them somewhere, and we should not disturb what we had already built, these 2. So this is the problem. This is white and red, and this is white and red. Okay, this goes here correctly. What for an economy of time, what we could do is we could see the piece which is besides this one, this red and white, which is here. It's a blue and orange. I can solve 2 edges at the same time. In fact, if I could bring, for example, this blue and orange, for example, I will do this and then I move it away and I bring the blue and orange and I do 2 times, and you see that I succeeded not only to couple white and red but also to couple blue and orange. So we could go fast by making this. Okay, now I see that I have yellow and blue. Okay, so I will bring yellow and blue. I will break here, and that's it. Now what we could do is orange and white. Okay, let's put it on the top right here. Orange white, this could come in its place. Let's see what's beside orange and white. We have green and red. Do I have green and red? I have it here. I will try to put it on this side. Okay, so here it is. I got this and I got that. What I'm left with is, Okay, I have blue and red. I have blue and red over here. Okay, I will put it correctly. So you have to, or sometimes you have to change the orientation of this edge in order to fit when you do the two turns. So if I bring it here, I need a blue. Okay, so this is the blue and white. This is what I do. I will put it there. I will bring this blue and white down to there, and it goes in its right position. Now I can do the green and yellow. So I will put this here, and I see that they fit. But I need to bring green and white here. So green and white, in fact, it should be, when I do this, and I do this, I need the green and white in this position. So let's get back to where we were. And I have to do something to change green and white and make it and that's it. Okay. And like this. So now we still have a problem. Okay. Okay. Now when I do this, no, I didn't fit correctly. Okay, so what we'll do is this. Okay. So, okay. So now when we do this and we bring it here, I move this. This green and white will fit correctly here, and I solved all the edges. Okay. So now what I have to do is to choose a face. Let's say we will solve the yellow face, sorry. And so we have this like this, and this goes here. It's a little bit like what we did when we solved this face, but the difference is that we instead of having one edge, we have an edge formed of a couple of pieces. And the last one is here, and I have built a cross. Now I have to put the corners. So okay, I will use the algorithm that I used on this one, if you remember, when I put a corner down in its position. You should have, in fact, yellow at the top so that it works correctly. And you should have opposite color, blue, red, blue, red. So it's 2LU, 2LU prime, 2L. Well, we know already that this algorithm switches the middle line, but the middle line or middle layer is already not constructed, so it's not a big deal. Okay, now we have this one that goes here, very simple. And I will use again this algorithm to bring this piece from here to there, 2LU, 2LU prime, 2L. Okay, and now I have built the yellow face. Now I will put these edges from here to there as I did in this cube, where I moved a piece from here to there, or an edge from here to there. Okay, so remember we have to have green on green, and orange, which is here, will go on this side. So I go back here, down, front, up, front, down, back, up, and I got it correctly. Now I can put this from here to there, back, down, front, and that's it. Now I should put this guy or this edge from here to there, back, down, front, up, front, down, back, up. So I have built, we have a parity. Okay, that's great. We will see how we can break it. In fact, you don't have, when you work on this 3x3x3, generally you cannot have a situation where you only have one edge which is reversed. Generally you have 2 or 4 that are reversed. And the algorithm that we do to switch them back is this one. As you see, I have flipped the white. If I repeat the algorithm, I flipped, and now I can flip these again. Okay, so now if we apply this algorithm here, it will not solve our problem, because this algorithm that I just did here, it will flip 2 edges, and I have only one that is flipped. So we will see that we have another algorithm that would change the situation. It goes like this, in fact. So we have to flip these correctly before continuing the solve. It goes like this. You take these 2 elements up to you. You rotate 90 degrees. Up to you, up to you, down to you, down this left side to you, down right side to you, up to you, down to you, and there it is. We have flipped these, and it is correct. We have not disturbed what is already constructed, and I have switched this edge doing this algorithm. So now what we will do is we will try to put the elements of the cross in their right position. As we said, we choose one element that is correctly placed, and we do a permutation on the others. Okay, so we have the orange, which is correct, blue, green, and red are not correct. So we will do an algorithm that would permutate, and it will bring this blue from here to there, the red from here to there, and the green from here to there. And it goes like this: up to you, down, you, up, you, down. And here I have placed all the edges in the right position. Now I have to resolve the corners. To resolve the corners, I have this one which is correctly placed, and I will do the algorithm that will permutate or recycle these 3. So this is correct. I will do an algorithm that will bring this from here to there, which is correct, orange, green to there, and blue, red to here, like this. So I should start it from here. It's up, u, prime, down, u, down, u prime. And I see that I have placed all the corners in their right positions. Now the last algorithm that I will do, it will permit me to flip this corner and this one and put the white on the top. So it goes like this. It's up to you, down, you, up, you, down, and I repeat it from this side, up to you, down, you, up, you, down. And the cube is solved.